Children, today we are going to learn about haloarenes. What is meant by haloarenes? Haloarenes are the compounds in which halogen directly attached to a benzene ring. For example, X I am writing. X means chlorine, bromine, iodine, fluorine. Halogen directly attached to a benzene ring. This is called as haloarenes. X means chlorine, bromine, iodine, fluorine. Now, here IUPAC naming nomenclature regarding haloarenes is some rules they are following for that. For example, take a compound like this. This is named as 1,1 dichlorobenzene or orthodichlorobenzene. This is named as 1,3 dibromobenzene or metadibromobenzene. One comma 3 comma 5 tribromobenzene. Here three different substituents are there. One is fluoro, second one is iodo, third one is bromo. How we are naming this means according to the alphabetical order. So, bromo, one bromo, then C, bromo, then F, 1, 2, 3, 4, 1 bromo, 4 fluoro, 2 iodobenzene, followed the alphabetical order. If more than one substituents are there, the halogens are arranged in alphabetical order. So in the haloarenes, the carbon atom is sp2 hybridized. The sp2 hybridized orbitals are shorter and holds the electron pair of bond more tightly. Now the halogen atom contains p orbital with the lone pair of electrons like this. This is the benzene ring. Benzene ring. Halogen X. It is having lone pair of electrons which interacts with the pi orbitals of benzene ring to form the pi extended conjugated system of pi orbitals. The delocalization of these electrons can be delocalized, that is, can move through the whole benzene ring, forming double bond character to CX bond. The resonance structure is given as follows. X halogen having 3 lone pairs. So if one lone pair shifted here, benzene ring X having 3 lone pair, if one lone pair shifted here, then this bond can be shifted here. So it is negative sign. Then other two bonds. Here double bond X, only 2 lone pairs and getting one positive sign since one pair shifted here. Then this can be shifted here and this can be moving out. So resonance, double bond X, 2 lone pair plus, here minus sign, since this is coming inside, here 2 bond, then once more, this bond shifted here, this is coming out, minus, double bond X, Then once more, this is shifting inside and this is shifting out. So resonance X 3 lone pair benzene ring. So this is the delocalization of these electrons, giving double bond character to CX bond, and the resonance structure of the halobenzene is given as follows. So due to this double bond character of CX bond, that is CX bond, the CX bond is shorter in length and stronger than in haloalkanes. So this is sp2 hybridized. This carbon is sp2 hybridized. The angle is 1.70 Armstrong. Now we can see the preparation, methods of preparation. Number 1, direct halogenation, that is benzene treated with the chlorine in the presence of ferric chloride. We are getting chlorobenzene plus HCl. This is the first preparation, chlorobenzene. Second one, from benzene diazonium chloride, that is benzene N2Cl, diazonium chloride. Here when treated with cuprous chloride and HCl, this is called a Sandmeyer reaction. If it is treated with cuprous chloride and HCl, we are getting same chlorobenzene. This is called as Sandmeyer reaction. If it is treated with copper and HCl, we are getting same chlorobenzene, but it is called as Gutterman reaction plus N2. This is called Sandmeyer reaction. This is called Gutterman reaction. Sandmeyer means cuprous chloride HCl. Gutterman reaction means copper HCl. Next, preparation of iodobenzene. Benzene diazonium chloride treated with potassium iodide, warm, that is KCl plus N2 plus this I joins here. So C6H5I, iodobenzene. Now preparation of fluorobenzene. Same benzene diazonium chloride treated with fluoroboric acid HbF4. HCl is removed. So C6H5N2BF4 becomes a salt plus minus. Then on heating we are getting C6H5F fluorobenzene plus boron trifluoride plus nitrogen. Next, commercial preparation of chlorobenzene, Rasching process. Rasching process, benzene treated with HCl and oxygen with copper chloride, 523 Kelvin, getting chlorobenzene plus water. Chlorobenzene plus water. Now some of the physical properties. The boiling points of monohalo, that is boiling points of the haloarenes, they are in the following order: iodo, bromo, then chloro. The melting point of para isomer, para means just opposite position, like this, para, opposite. This is higher than the melting point of the ortho and meta isomers. These are the ortho position, these are the meta position. The higher melting point of the para isomer is due to its symmetry, which leads to more close packing of its molecules in the crystal lattice and strong intermolecular attractive force, which requires more energy for melting. So, para dichlorobenzene melting point greater than orthodichlorobenzene greater than metadichlorobenzene. That is dichloro. This is para dichloro. This is metadichloro. This is orthodichlorobenzene. Next, solubility. Haloalkenes are soluble in water because they cannot form hydrogen bonds with water, but soluble in organic, insoluble in water, soluble in organic solvents. Next, density. Iodobenzene is greater than bromobenzene, greater than chlorobenzene. Next, some of the chemical properties. Reactions involving halogen atom, that is aromatic nucleophilic substitution reaction. Substitution: chlorobenzene with the sodium hydroxide at 350 degrees Celsius. NaCl is removed, C6H5OH, phenol plus NaCl. This reaction is known as Dow's process. Chlorobenzene with ammonia at 250 degrees Celsius, 50 atmosphere. HCl removed, remaining C6H5NH2, aniline plus. If you are taking two molecule means NH4Cl, aniline. This is phenol. Next, once more, chlorobenzene treated with copper cyanide at 250 degrees Celsius in the presence of pyridine, forming that is phenyl cyanide plus copper chloride is formed. These are the nucleophilic substitution reaction. Next, reaction with metals, that is Woods fitting reaction. Woods fitting reaction. Chlorobenzene treated with sodium, two molecules of chlorobenzene, giving that is chlorobenzene, chloroethane. NaCl removed, two NaCl removed, so remaining C6H5C2H5. Ethyl benzene. This reaction is called as Woods fitting reaction. Next, fitting reaction means both are chlorobenzene. C6H5Cl plus 2Na plus C6H5Cl. NaCl removed, giving C6H5 biphenyl. This is called as fitting reaction. This is called as Woods fitting reaction. Next, reaction involving aromatic ring, that is electrophilic substitution reaction. Chlorobenzene, when treated with chlorine in the presence of ferric chloride, we are getting two products. Cl, orthodichlorobenzene, this is the minor product, plus para-dichlorobenzene, this is a major product. Next, treated with nitric acid, corn nitric acid and corn sulfuric acid. ClNO2, orthochloronitrobenzene. Similarly, parachloronitrobenzene. When treated with the sulfonation, that is fuming sulfuric acid, this reaction is called a sulfonation reaction. SO3H group is in the ortho position, orthochlorobenzene sulfonic acid, and SO3H group kept in the meta position. Next, Friedel-Crafts alkylation reaction treated with anhydrous AlCl3 aluminium chloride and methyl chloride. A methyl group is kept at the ortho and para position. orthochlorotoluene plus parachlorotoluenes. Next, reduction, fourth reaction, reduction, chlorobenzene, that is C6H5Cl on reduction, forming in the presence of nickel aluminum alloy and NaOH, forming benzene C6H6, one hydrogen added here and one HCl removed outside. Reduction. Next, formation of the Grignard reagent, chlorobenzene C6H5Cl treated with magnesium in the presence of tetrahydrofuran, just both combined C6H5MgCl. This is the Grignard reagent. Next, what are the uses of chlorobenzene? It is used to manufacture pesticides like DDT, used as a high boiling solvent in organic synthesis, used as fiber swelling agent in textile processing.